The moon example, the Earth and the moon and the sun, and let's find out the combined gravity on the moon due to the Earth and the sun if the moon is in some kind of arbitrary position. So this would be kind of any kind of problem that would ask the combined gravity. You've seen this in electricity when we did chapter 23. I asked, there were several charges, and I asked what is the total force on the third charge. So now I'm just applying that same kind of concept and problem to the planets and gravity. So let's say here is the sun, here is the Earth. Let's say the moon is in some kind of position like this. We could of course do also Venus or any other planet. But since the gravity on the moon due to the Earth and the sun are similar, I'm choosing that as an example. The gravity, let's say this angle here is a 40-degree angle. So the moon is going around the Earth. This would be sort of like a crescent phase of the moon. We would call this the crescent phase. A little bit of it would be visible. If the angle is 90, then it would be first quarter or third quarter phase of the moon, depending on how you look at it. So it would be first quarter phase of the moon. So this is roughly about crescent. So let's find out the total gravity. The gravity of the sun on the moon, we already calculated 4.358 times 10 to the 20th. I believe there was something like that, 4.358 times 10 to the 20th newtons. And then gravity of the Earth on the moon is equal to 1.983 times 10 to the 20th newtons. So what would be the combined gravity on the moon? This is known as a three-body problem. It's very, very hard to solve this in physics because to solve the general path of the moon. But we could solve it particularly right there. What is the combined gravity of the moon? So this one, you can add it to here. The moon is going to be experiencing a gravity like that. So it's going to be kind of going this way. So it's going to experience gravity due to the sun and the Earth. So we have to divide that up into components and add them. So let's call this F1 and F2. Okay? And so we'll call this alpha, okay? And then we know this angle already, right? This angle is 40. So F1, F total x is going to equal F1x plus F2x. And F total y is going to equal F1y plus F2y. So F total x is going to equal F1x. So that's going to be this thing times, if this is alpha and this is alpha, they're the same angle, right? So F total x is going to equal F1x. So 4.358 times 10 to the 20th times cosine of alpha, okay, which is to the left. So we could just put a negative there, times F2x, which is going to be positive this way. So it's going to be 1.983 times 10 to the 20th times, let's see here, if this is 40 degrees from the horizontal, this is also 40 degrees. So I'll turn it interior angle, so we can just take 1.983 cosine of 40. Okay? Now, what is this angle alpha going to be? Well, we don't really even need to calculate cosine alpha. All we really need is the distance, this distance, right? And then this distance, we already know. So what was the distance from the Earth to the sun to the Earth? I'm actually busy. Yeah.
I forgot to return your hands off. Yes.
Okay.
Thank you.
Yeah. Okay, so let's continue here. So we're gonna have to do 4.358 times 10 to the 20 cosine alpha, and then over here you're gonna have f total y is gonna equal 4.358 times 10 to the 20th times sine of alpha, but negative because it's down, and then negative of this guy, so f2, it's going to equal negative 1.983 times 10 to the 20th sine of 40. Okay, 3.844 times 10 to the 8 meters. So okay, so what we could do is we could call this D, which is going to be very, very close to the 1.496 times 10 to the 11th, very close. But if we wanted to exactly determine what that was, we could make a triangle. Here is the D. Here is 40 degrees, D, and then here is the 1.496 times 10 to the 11th. Here is 3.844 times 10 to the 8th. And we could say D squared, let's write it here. D squared is equal to this squared plus this squared, law of cosines, minus 2 times the product of them, times the product times cosine of 40, times cosine of that angle. So, but we are gonna get, I do expect that we get an answer very close to 1.496. So you go 1.496 times 10 to the power 11 squared plus 3.844 squared times 10 to the power 16 minus 2 times 1.496 times 3.844 times 10 to the power, that's going to be power 19 times, let me make sure I'm in degree mode, times cosine of 40. So I get some number here, then I'm going to square root it to the power of 0.5. 1.493 times 10 to the 3, 6, 9, 11. Okay, so pretty close here. 1.493 times 10 to the 11. Okay, so from here we could calculate alpha, right? We could do sine of alpha over this is equal to sine of this over this. Use the law of sines here. Okay, so let's erase this now. Sine of alpha over 3.844 times 10 to the 8th is equal to sine of 40 over 1.493 times 10 to the 11th. Okay, so you're going to take sine of 40 times 3.844 times 10 to the power 8 divided by 1.493 divided by 10 to the power 11.